This will get started. Hello, everyone. This is Darla Saunders here, and on behalf of the Atlantic Salmon Conservation Foundation and the Canadian Rivers Institute, I'd officially like to welcome you to the fourth webinar in our series. This webinar series is made possible in part thanks to the contribution of the New Brunswick Environmental Trust Fund. We're very pleased today to be hosting Levi Cliche, Manager of Program Delivery with the Clean Annapolis River Project in Nova Scotia, also known as CARP. CARP is an NGO based in Annapolis Royal with a mission to restore and protect the ecological health of the Annapolis River watershed through science, leadership, and community engagement. Levi has been involved with the organization since 1998 and has delivered a variety of projects ranging from fish habitat and riparian zone restoration work to agricultural greenhouse gas emission reduction projects. So just before we get started, a few housekeeping matters. We're going to save questions for Levi until the end of his presentation. When the question and answer period starts, you can ask a question by using the webinar control panel, which is the little gray box that you should be seeing at the top of your screen. If it's minimized, hit the orange arrow to enlarge it. You can use the audio of your computer by raising your hand. That's the little yellow icon, in which case we'll unmute you and you can speak directly to Levi and ask a question. Or you also have the option of typing in your question on the control panel and we'll read it aloud for you during the question and answer session. If none of the above is working, please email me your question and I'll read it aloud. So my email address is darla, D-A-R-L-A, @salmonconservation.ca. So I will now turn the webinar over to Levi.
Good morning, everyone. I'm really happy to have the opportunity to talk about this project. Yeah, I'd like to thank Darla and Michelle for the opportunity to present this to all of you. So this presentation, what I'd like to do is cover the various steps that led to the removal of the Clemensport Dam, starting with some of the preliminary work, the pre-restoration feasibility study, through to post-removal, the monitoring, and what is going to take place for project evaluation in the future. So this really is kind of my perspective on the project over time. Most of this was seen through through to the actual removal of the dam by Andy Sharp, who's the science coordinator for CARP. Hello?
Sorry, everyone. I think Levi's got a touchy.
Am I back?
Yeah, you're back. You must have moved.
Yes, you're back.
Oh, good. Okay, hopefully this doesn't happen too many times. So I'll pick up where I left. Oh, no. Am I? Hello?
You're good. You're good.
You are coming through. You are coming through.
Oh, I am. Okay, I'm not hearing very well through my speakers. Okay, so I guess I was saying that the project was seen through to the removal by Andy Sharp, who's the science coordinator, was the science coordinator for CARP. Am I still coming through?
Yeah, you're okay.
Yes, you are. Yes.
Okay. So Andy oversaw the project through to the removal of the dam. I was around, not directly involved in the project until afterward. So I got involved more through the post-restoration monitoring and will be involved through the evaluation of the project. So anyhow, I want to get going before we take too long on this slide. So the Clemensport Dam project could be seen as part of CARP's overall aquatic connectivity program. So this has been going on since about 2006, where we've been auditing culverts in the watershed. Throughout the project, I guess, 2006, we had 1 year of culvert identification and restoration, in which this was about 16,000 or 1,600, sorry, road crossings were identified in the watershed. So every year we try to visit a large portion of these and conduct assessments for fish passability. It seems pretty consistent that every year we find that 50% or 55% of what we visit are barriers to fish passage, which is consistent with studies that DFO has conducted. So this really has to do with dams, is that dams, of course, are another barrier to fish passage. Nova Scotia Environment has about 602 dams on record in Nova Scotia, and I guess about 57% of rivers entering the Bay of Fundy have barriers. So of course, if upstream habitat isn't accessible to anadromous fish, it's going to be difficult to restore populations. So on to the Moose River itself. The Moose River is tributary to the Annapolis River. It runs in the Annapolis Basin below Annapolis Royal, where there is a causeway that could be considered a bit of an impediment to fish passage, and also a potential cause of mortality on downstream migration. So luckily the Moose River is isolated from that. The dam itself is located about 1.8 kilometers upstream of the confluence with the Annapolis Basin, so it cuts off a large portion of the habitat in the river. You can see the location of the dam there. The main stem, or the west branch of the Moose River, is approximately 11 kilometers long. That's where the dam is located. One of the other reasons we looked at the system, the Moose River system, is the pH is pretty well buffered in that system. Unlike a lot of rivers in Nova Scotia, it runs through some limestone-bearing geologic formations. So the pH ranges typically from 6.5 to 7.0. The system historically hosted large runs of Atlantic salmon. Local residents in the area actually had reported fairly recent sightings of Atlantic salmon pooling below the dam, and were quite concerned because they did mention they were subject to poaching. Yeah, DFO had conducted surveys in the past that had deemed most of the upstream reach on the west branch of the river suitable for spawning and rearing of Atlantic salmon. So the Clementsport Dam itself was built around 1942 by the Department of National Defense. It was to provide a water supply for nearby Cornwallis Naval Base. It was used by DND till about 1967 when the adjacent property was sold to Annapolis County, who held it until the 80s. They leased it to Clementsport Legion. The area had been used as a swimming hole from, I guess, the 60s onward, but in the 1980s, the Clementsport Legion operated a community swimming park complete with picnic areas, lifeguards, and whatnot. Over time, they didn't really have the funding or the ability to keep the dam up or to monitor the swimming area, so they turned it over to a not-for-profit group, which is no longer active. So the result of that is that over 10 years before the dam was actually removed, there was no maintenance done to the dam. So high spring flows, spring ice had damaged the dam. There was some undermining that was happening. The system, or the dam itself, was collapsing, and it was starting to pose a public safety risk. There was a fish ladder on site, but again, that wasn't maintained either, so it wasn't active during the time that the community group was running the dam. So you can see an upstream view of the dam. You can see the boulder and log crib work that's beginning to collapse. And here's a view looking downstream. So you can see again that most of the dam structures degraded quite heavily, and that there's quite a buildup of sediments behind the dam. I guess CARP had the dam in its sight, so to speak, for a fair bit of time. There was some community concern about it, and the fact that it was causing an impediment to fish passage. So really, I guess around 1999, we started seriously looking at the project and collecting a bit of baseline data, which fed into a feasibility study that took place in 2010. The feasibility study led to a restoration design, a restoration, and throughout the process, a lot of monitoring was collected basically to get a baseline and to monitor the process of the project, and in the long run to evaluate the success of the project. The feasibility study, I'm going to talk quite a bit on this slide. I know it's not very exciting visually, but this is a very important part of the process. CARP hired a team of consultants. Basically, it was Parish Geomorphic, AECOM, and McAuliffe Environmental Engineering to complete the study. There were a lot of aspects that were looked at, as you can see on the list there. One of the first ones, and a bit of a difficult one, was the title search, where the dam or the properties around the dam had changed hands so many times. No one really knew who owned the dam or wanted to really take responsibility for the dam. So legal counsel had to be retained, and basically they determined that no party had clear title to the dam. So it was pretty much open for removal. Um, they conducted site surveys while using various information, historic documents, aerial photos, topographic maps, a lot of whole ground surveys and ground truthing, just to gain an understanding of the dam's role and impact in the watershed. Um, they developed a hydraulic model. Basically, they wanted to use a hydraulic model to predict the outcomes of various different restoration options, and see how basically well removal or other options would affect the hydraulics and sediment movement within the system. An archaeological assessment was required under the Nova Scotia Special Places Protection Act to make sure that the site wasn't of any major historic significance. It was determined that the site was of low archaeological potential. An engineering review of the dam determined that the dam was at high risk of failure, and if the dam did fail catastrophically, it posed quite a risk to public property and public safety. There's a roadway with a large culvert downstream that would have potentially been clogged up by the debris from the dam. There's private properties and homes downstream. The dam itself was collapsing. It's very accessible to the public, so they believe that it was quite a risk to the public. Community consultations were to be a pretty important part of this process. So in July of 2009 and in April of 2010, community consultation meetings were organized in the community itself. These were fairly heavily advertised. About 300 letters were sent out to homeowners, residents in the area, to try to get their participation. The meetings were also advertised in the papers, but unfortunately, not a lot of attendees came to the meeting. We had, I think, 10 to 20 between the two meetings, and yeah, there was maybe a couple of people vocal for each side of, pro removal or those who wanted to keep it and maintain it as a swimming park in the long run. So unfortunately, really, because of public apathy, there wasn't really a whole lot that could be brought into the feasibility study from that point of view. So in the long run, the conclusion was that the complete removal of the dam was really the best option. The consultants used a decision matrix basically to remove any bias toward one option or another. So it actually generated a score based on several criteria, and it, by far, complete removal had the highest score. Another aspect that was taken into consideration was whether or not there was a likely proponent for each of the options. So the only ones that really had a viable proponent were either to do nothing with the dam or to remove the dam completely. So again, because of the hazards to public safety that were inherent with doing nothing, the complete removal was the option that was preferred. Of course, any project like this needs a decent design, permitting and funding. So yeah, basically the restoration was designed, it was developed by Parish Geomorphic with input from CARP, the National Oceanic and Atmospheric Administration, and the Gulf of Maine Council on the Marine Environment. They're both partners throughout the project and contributed a great deal of experience and knowledge to the project itself. We needed to get release documents from adjacent landowners. So those were some of the people who had owned the property in the past and owned bits of adjacent land. So the county of Annapolis, the province of Nova Scotia, the federal government, as well as a couple of private landowners that live nearby. We needed a watercourse alteration permit. Obviously, there's quite heavy work being done in channel, so that was obtained from Nova Scotia Environment and Department of Fisheries and Oceans. And where the consultants had estimated the cost of the removal of the dam would cost about $260,000, a lot of funding applications went into quite a wide variety of funding sources. So Basically, throughout that process and leading into the dam removal, a lot of pre-restoration baseline monitoring took place. So we'd have an idea of how the system was functioning and what the habitat quality was like before it was taken out. We can compare it with some of the post-restoration work. Fish habitat utilization was conducted using fight net surveys in 2009, and this actually fed into the consultant's report as well. Water quality was conducted regularly by CARP staff using a data sonde, in this case a Quanta Hydro Lab, to measure the parameters that you see on the screen. Benthic invertebrates have been sampled since 2009 at the site annually. They're sampled using the cabin protocols. Photo point stations were established at 4 different sites along the restoration site. So basically determined an angle and a height to take pictures from, looking upstream, downstream, and across the dam in both directions, just so we can get an idea of the changes in channel, riparian vegetation, etc. over the course of the project. And monumented cross-sections in 2009 were established by students from the Center for Geographic Sciences, or COGS, locally. So they established 15 monumented cross-sections that we could later use for some of our measurements. I'll get into that a little further into the presentation. So a little more on the fish habitat utilization. Just wanted to mention this because it was actually conducted by local volunteers. What they did, they wanted to determine whether or not there was actually a remnant population of Atlantic salmon or other anadromous species of concern in the area. So they set a fight net about 400 meters up from the Annapolis basin, so well below the dam site itself. On September 7th of 2009. It was left in place and checked every 24 hours until October 4th, 2009. If no one was able to actually check the net on a 24-hour basis, it was able to be closed shut so that it wouldn't actually, trap anything and risk actually, leaving things in there until they died. So. Anyway, this determined that there were remnant populations of salmon in the stream. There are also brook trout utilizing the stream, as well as quite a few American eel. So on to the restoration, I guess it wasn't just a matter of throwing a stick of dynamite at the dam, letting it go and letting the river flow through. The consultants, Parish Geomorphic, who actually did the restoration design, had quite a few actions that they had identified as necessary if we were going to remove the dam. I'll get into these in a little more detail, but just to give you the list. So an overview of the area itself. I guess here's the dam, the fishway on this side, on the eastern bank, and a bit of a concrete abutment here. You can see, I guess, above at the head of the head pond area, a cobble bar. This is actually accumulated large alluvial sediments that have built up over time because of the slowing of velocity. So there's a bit of a gradient between here and here. Given that the sediments would have to be removed from the head pond area. There's also a bit of land forming around here. There's a picnic area. Again, on this side, there was an earthen embankment that was used to retain some of the flood waters as they built up behind the dam. We also had a road to contend with. So the Clementsport Road runs extremely close to the river. At some points, I guess the horizontal distance is only a few meters, 4 or 5 meters. So this bank is actually built up really large boulder, and the road bed's built on top of it. So there was some concern about undermining of the roadway, potential impacts to provincial property and public roadway. So step by step, the removal process was to start with the earthen embankment alongside the dam and regrade it. So it was quite steep. I can't give you the exact ratio off the top of my head, but it was regraded to a 3:1. So this was to provide greater stability. Of course, while we were working on site, erosion control measures were used to prevent sedimentation and, of course, erosion of the bank. So what happens, this was pulled back. At the foot of it, erosion control blanket was installed, and then boulder was installed along the foot of the bank. The disturbed soils along the top, as soon as the excavator was moved away, was covered in hay, seeded, and then later planted with trees. So you can see here exactly where the, well, generally where the area is that work took place. The actual removal of the fish ladder and the dam itself took very little time. Extremely easy. They used an excavator with a thumb attachment on it to basically break apart the dam and lift it out by chunks. The pieces were then transported off-site and disposed of. So again, this is the area where that took place. At this point, the concrete abutment on this side where they're standing here wasn't removed. It was left in place till some of the other work had taken place. Up in the area where I mentioned there'd been some buildup of sediments, cobbles, and whatnot. The stream bed had to be regraded, so the sediments at this point had been removed from the impoundment area, and there's a fair change in slope between these two. The base of the river had changed here, but not quite so much here. So a lot of the material here was removed. Some of it put aside for some later work that was going to be done on site. Anyhow, so the 3 riffles in this area were constructed to help slow the water flow through the area and to make for a little bit more complex habitat. Also, where the bank on this side had been built up somewhat and was subject to erosion, and also keeping the river from accessing its floodplain in this general area, it was regraded in order to allow that, and then stabilized with hay and grass, similarly to the area where the earthen embankment was. I had mentioned the roadway earlier and the risk of eroding under the roadbed. So the consultants had recommended that 3 deflector weirs be built alongside the roadbed to allow for the accumulation of debris, of substrate in the area alongside the roadbed, to bolster it, as well as to try to divert the channel flow a little more eastward, so that it wouldn't be causing any issues in here. So those, well, of course, were built at the same time, 2011. Most of the hydrological, I guess the design was based on 2-year high flows. Unfortunately, I guess last winter we didn't have a lot of snow. We didn't get a really good freshet, so we haven't really seen those function the way they were expected to at this point. So hopefully this year, if we get a good freshet, we'll see some accumulation in this area and a bit more of the channel moving over here. At this point, there's a bit of a gravel bar in the center here, and we have a bit of a split channel going around both sides. Upstream, they'd identified a risk of head cut. So where the channel, let's see, within this area had been regraded so much, I guess there was a risk that the river would continue to erode the stream bed upstream of that area, and continue to cut back. So what had happened, the upstream margin of influence of the dam, what they did was excavated the stream bed and installed a really large boulder at grade, and then bolstered the stream bank on the western bank, which was quite steep and well cut into, eroding at the time. On this side, the stream bank's quite shallow. It's more or less floodplain, so very little risk of erosion in this area. The final step using heavy equipment was to remove the concrete abutment on the eastern bank. And this was done using the excavator, broke it apart, ripped it out in chunks, carted it off-site, fairly straightforward. At the end of all this, the site pretty much looked like scorched earth. There'd been a lot of equipment through there. Basically, there's a lot of gravel, cobble, whatnot, disturbed soil. So there's a lot of effort to stabilize and revegetate the site. Again, using hay and seeding in a lot of the disturbed soil areas. Also, pretty much immediately had students come out from the Nova Scotia Community College who helped to plant some of the trees that actually had been scavenged when some of the regrading had happened. So we'd put some trees aside and replaced them in the area that had been disturbed. They're still doing quite well. Also at the time they used some willow stakes, planted willow stakes that we'd saved over the summer, left over from another project to try to get that vegetation started. Unfortunately, it was quite late in the year, and they'd already flushed a bit, so most of those weren't successful. However, this spring we did have staff go out with dormant stakes and plant 600 in the area, a lot of which actually took quite well. So these are a combination of willows and red osier dogwood. You can see along the margin here. Yeah, they sprouted. Whoops, they sprouted quite well. Here we go. Oh no, I had gone back. And yeah, in the spring we also had the Middleton Girl Guides come out. They purchased 50 potted trees, so a combination of yellow birch, red oak, American elder, and high bush cranberry, and planted those on the site in freezing cold temperatures. They did really well, and yeah, those trees are doing excellently. So here you can see a gravel bar a little farther into the downstream reach where the willow stakes are actually starting to sprout. This is a bit late in the spring. So again, these are still doing quite well. They put on pretty good whips, and they seem to have fared quite well. So for post-restoration monitoring, most of these things were done throughout, well, from pre-restoration through to the restoration and continue now. Water quality was conducted at minimum monthly at 4 sites, so 1 site below the dam, 3 sites above. Again, using a multi-parameter data sonde, either a YSI or a Quanta Hydro Lab. We had data loggers since 2009, both below the dam site and above the dam site, tracking water temperature. Those, I think they were taken out about a month ago. We've yet to download the data from this year and compare it to previous years. That's going to be done in the evaluation of the project. Stream discharge again was collected throughout the project, several different sites. So downstream of the restoration site, upstream of the restoration, immediately upstream that is, and 2 control sites that were several kilometers upstream. So this to measure the hydrologic impact on the dam removal. Benthic invertebrates, which I mentioned before, have continued. We sampled them again this year. Anecdotally, I guess, when we were sampling the head pond area of the dam previously, we were picking up a lot of leeches and snails and organisms that indicate fairly poor water quality. The year of the removal is only, well, we'd done that cabin sampling about a month after the equipment moved out of there, so we didn't see a whole lot of anything. But this year it seems to be getting colonized with quite a few mayflies and stoneflies, so it seems to be pretty encouraging. Photo point stations again continue. I've already explained those, so I won't go into that anymore, other than the fact that a lot of the times when we go out to the site for other reasons, we do take photos. The monumented cross sections were finally used, so we used the 15 monumented cross sections to do cross-sectional profiles of the dam post restoration, and that will be done annually. We just actually got done this year's this week. A little cold in there, but anyhow, we're getting cross-sectional profiles, foul wag depths to get longitudinal profiles of the channel to track changes in the channel over time post-removal. We also are using some of those cross sections to conduct vegetation surveys within the project area, so that we can get so that we can track changes in vegetation from the revegetation efforts, and also from natural colonization. Grain size analysis, we use Woolman 100 pebble counts, basically randomly grabbing 100 pieces of substrate from the transect and measuring them, just to get an idea of the general makeup of the substrate. So over time we'll be able to track changes in substrate composition resulting from the dam removal. And fish passage assessment, we conducted electrofishing surveys immediately before the dam removal at 4 sites, 1 below the dam, 1 within the work area, and then 2 upstream. This was done in 2011, also post-removal in 2012. Unfortunately, no salmon yet, but it's still fairly early. I hope to get out again and assess the site in future years. So. Anyhow, there's some photos of some of the post-restoration monitoring work. This is a staff member conducting some of the pebble count, measuring some of the substrate, discharge surveys, measuring water quality, and here's a brook trout caught in our electrofishing surveys. So this is a view of the dam before restoration. Showed this picture before, but I wanted to contrast it with a view, I guess this spring, post-restoration, what it looks like today pretty much. So it's a nice clear upstream view of the stream. As you can see, there's, well, just barely, there's a bit of a braid there. So the water is actually, there's a fair channel coming around here that you can't quite see in the picture. But over time, what we're hoping to see is the stream should hopefully follow this course through, and that the channel will be a little more defined in this area, and vegetation will build in these areas. So on to lessons learned. I'm going to, if you'll forgive me for it, read these out. These are actually Andy's observations. I thought it'd be appropriate to include them here, where he was very directly involved in the entire process of the removal, well, and also the pre-restoration work. So yeah, just to read directly from Andy's notes, it takes time and money to remove dams. So what he's got to say is that restoration projects take time to conceive, evaluate, design, undertake, and monitor, so be prepared for multiple years from start to finish. Every dam removal has issues. Every project will likely have one or more problems that must be addressed before work can proceed. So these might be archaeological remains, contaminated sediments, etc. In our case, it was property ownership. Following a title search and legal review, it was determined that it was unclear who owned the dam, so hard to pin responsibility on one person for the removal. Dam removals can yield significant habitat gains. So one single dam restoration can yield access to many kilometers of spawning and rearing habitat. In the case of the Clementsport Dam removal, approximately 19 kilometers of upstream habitat was gained. And finally, dam removals are messy. So removing wood, sediments, and concrete around moving water is challenging. It's difficult to pump water around, control the sediments, minimize impacts. You need to ensure lots and lots of advanced conversation with key regulators to identify concerns and discuss project plan. So short-term effects, days to weeks from the construction, can address long-term barriers that may have been around for decades. And that's the end of the presentation. So thanks very much for the opportunity again. And thank you to all our funders. There were many. I don't think they could all fit on this page, but the vast majority are here.
Thank you, Levi. That was excellent. It's fascinating to hear all of the steps and work that's required behind the scenes to do something like a dam removal. That was really instructive and helpful. Thank you.
Thank
so
you.
We'll open the floor now to question and answers. So again, you can ask a question by raising your hand using the little yellow icon, and we can unmute you so that you can speak aloud, or you can type in your question.